Hi, this is Mr. Ross at Parkview High School, and this video is about the fundamental counting principle. And the first question is, draw a true diagram. I generally don't draw a true diagram. I suggest you use blanks and stuff instead. Here's the first question. You go to a snack bar to buy a bagel and a drink for lunch. You can choose from a plain bagel, a blueberry bagel, or a raisin bagel. The choices for a drink include water or a sports drink. How many different lunches can be made from these choices? So I'm going to start off with blanks. And this is going to be your bagel option. This is going to be a drink option. So in your bagel option, you have options of a plain bagel, a blueberry bagel, and a raisin bagel. So you got 3 options. And for your drink options, you have water or a sports drink. So you got 2 options. So our answer is 3 times 2 are 6 choices. So it's pretty easy. Fundamental counting principle, just in short, it basically means you're going to multiply all the numbers you're given for different sets of things. But sometimes it can be tricky. So you should start off with blanks. But most of the time, it's going to be that. Number 2, when you get ready to get dressed for school, you open your closet to find that you have the following choices: a red, blue, or white shirt, jeans or sweatpants, tennis shoes, or sandals. How many different outfits can be made? So I got 3 things I'm wearing. I have to wear a shirt, and I have to wear pants, and you have to wear shoes. So in my shirts, I have a red, blue, and white. So I got 3 options for my shirts. For my pants, I have jeans and sweatpants, so I got 2 options for that. And for my tennis shoes and sandals, so I got 2 options for those. So the answer is going to be 3 times 2 times 2, which is 6 times 2, so it's 12. So it's 12 outfits can be made with that information. Alright, so pretty easy, right? Let's try a new one. Alright, so the next example says, a restaurant offers 4 sizes of pizza, 2 types of crust, and 8 toppings. How many possible combinations of pizza with only 1 topping are there? So that basically means you can't pick all 8 toppings. But we got 3 different categories. We got a size category, we have a crust category, and we have a topping category. And of my sizes, I have 4 different choices. Of the crust, I have 2 different choices. And my toppings, I have 8 different choices. So still the same, 4 times 2 times 8. That's 8 times 8, so 64 pizzas can be made with that information. Number 2 says, how many ways can 5 paintings be lined on a wall? So let's say we had 5 paintings. This is painting X, painting A, painting B, painting C, painting D. 1, 2, 3, 4, 5. So I can rearrange this order in lots of different ways. So let's think about this. If I did, I got 5 blanks. This is my first painting, second painting, third painting, fourth painting, fifth painting. So I got 5 options for my first painting. It could be D, A, B, C, or X. I got to choose only one of those. Let's say I got 5 options for this place. After one of those is chosen, I've got 4 options left for my next space. Then after one of those is chosen, I got 3 options left for the next space. And after I choose one there, I got 2 options left. And then for my last space, I only have 1 option left. So if this is true, I've got 5 paintings that have the rearranging on the wall. My ways of rearranging them is 5 times 4 times 3 times 2 times 1. So it's 20 times 3 is 60 times 2 is 120 times 1. So it's 120 ways you can rearrange that. So just for the record, you want to test on this, but I can't help but mention it. You ever see 5 times 4 times 3 times 2 times 1? It basically means 5 factorial. You may see that at some point in time in SATs or ACTs or some other class. But whenever you're multiplying all the numbers following certain numbers, like 5 times 4 times 3 times 2 times 1, or if I gave you 6 times 5 times 4 times 3 times 2 times 1, this would be 6 factorial. It's like an exclamation point. But again, I don't think we tested you on it, but yes, it's true. And that's what the word is, factorial. The little exclamation point in math basically means factorial. All right, last example. It says the menu for high school cafeteria is shown below. And this is all the information they have on the menu. Determine the number of possible meals consisting of a main course, a vegetable, a dessert, and a beverage that can be selected from the menu. Determine how many of these meals will include a chicken tender. If a student chooses pizza, corn, carrots, or dessert, and a beverage from the menu, determine the number of possible meals that can be selected. So this question has 3 parts. It first says determine the number of possible meals consisting of a main course, a veggie, a dessert, and a beverage that can be selected. So that's the first part. Some answer here on the sheet of paper. For the main course, we have 1, 2, 3, 4, 5 options. This is my main course. I got 5 options. I have to have a veggie. And I've got 3 options. I have to have a dessert. And for that, I have 5 options. And I have to have a beverage. And I've got 3 options. So the answer to the first question, it would basically be 5 times 3 times 5 times 3. So 5 for the main, 3 for the veggies, 5 for dessert, and 3 for the veggies. So that's 15 times 15, so that's 225 options. The second part says, determine how many of these meals will include chicken tenders. So in that part, we want a meal that includes chicken tenders. So in that case, we don't use all 5 options for the main course. In the main course, I have to include chicken tenders. So I don't use all 5. For my first blank, for my main, I only have 1 option. And then everything else is still the same. So I got my veggies, I got my dessert, I got my beverage. So for my veggies, I still have 3 options. For my desserts, I still have 5 options. For my beverage, I have 3 options. So 1 times 3 is 3 times 5, that's 15 times 9, so it's 45 options. That includes chicken tenders. So that answer would be 45 options for the next set. The next question says, if a student chooses pizza, corn or carrots, a dessert, and a beverage from the menu, determine the possible combinations. So in that case, the student is not going to choose all the options. So far I got blank 1 for my main, I got another blank for my veggies, a blank for my dessert, and a blank for my beverage. For my main, he said he has to choose pizza. So I only have 1 choice there. It has to be pizza. For my veggies, it has to be corn or carrots. So only it could be corn or it could be carrots. So I have 2 options for my veggies. And then it says that his dessert can be anything and his beverage can be anything. So I still have 5 options for my desserts. I got 3 options for my beverages. So that gives you 2 times 5, which is 10. Or 1 times 2 times 5, so it's 10 times 3. So it's 30 options for that question. Anyway, that's the fundamental counting principle. I hope you figure out that that's not that hard to do. That's all I have. Good luck.